Hey everybody, welcome to Chapter 5, Section 2, Medians and Altitudes of Triangles. To start off this video, let's go over what it means to be a median of a triangle. So a median of a triangle is a segment with endpoints being a vertex of a triangle and the midpoint of the opposite side. Every triangle has three medians that are concurrent. This word "and" shouldn't be there. Concurrent means that they are intersecting or meeting at that spot. So the point of concurrency of the medians of a triangle is called the centroid, and it is always inside the triangle. So in this example here, CD, see how it's coming from the vertex, the line, and then it's intersecting with one of the sides of the triangle. So CD is a median of triangle ABC, and therefore it is creating, like point D is a midpoint of AB, so it's creating two congruent line segments, AD and DB. So with that in hand, we're going to look at this picture and identify the medians of triangle ABC, and then we'll identify the centroid of triangle ABC. That part shouldn't be too difficult. You can probably guess that right off the bat. Point U is going to be the centroid of triangle ABC, because you can clearly see all the lines on the inside of the triangle meeting at this point. So let's identify what the medians are. Remember, the medians have to come from the vertexes or the corners, if you will, of the triangle. So CF is a median, not CU, because it's got to extend all the way to the other side, the opposite side of the triangle. So CF is a median, AD is a median, again, not AU or UD. The reason why it wouldn't be UD is because that is a median of triangle UCB, and we're looking at the medians of triangle ABC, so the big triangle. So we can't use any of these little medians that come from the point U, okay? So where was I? AD, CF, and then BE, okay? Those are going to be the medians of the triangle ABC. So now let's talk about the centroid of the triangle. Right? So the centroid is the point of concurrency of all the medians. And so we have something that we can extrapolate from that called the centroid theorem. And that states that the medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so what does that mean? It says, in this example, if P is the centroid of triangle ABC, then AP is 2/3 of AK, BP is 2/3 of BL, and CP is 2/3 of CJ. So let's see what they mean. Okay, so AP is 2/3 of AK, BP is 2/3 of BL, CP is 2/3 of CJ. That's what it means. Okay, because those were all the medians, right? And so the side length, or the segment, that is coming from the vertex is going to be 2/3 of the whole thing. So that means the segment coming from the centroid to the edge or the side of the triangle, that's going to be 1/3 of the whole length of that median, okay? Because 2/3 plus 1/3 is 3/3, right? Okay, so in this example, we're going to use the properties of that centroid theorem. And so in triangle CDE, the point U is the centroid. And so they're giving us this information. UK is 12, EM is 21, so I kind of labeled that myself. EM is 21, and UD is 9. And then we're going to figure out all the other missing segments of the triangle. So we're going to use that 2/3 property, and then remember, every time a median touches a side of the triangle, it's going to create two equal or congruent segments, okay? So looking at the first part of this example, we're identifying what CU is. And so I wrote CU is 24, and I did 12 times 2. So let's look at why I did that. So CU is right here, and we are given 12, and that's UK. So this is the 1/3 side. How do you know it's a 1/3 side? Because the 2/3 side, by definition, comes from the vertex. So CU is the 2/3 side. and UK would be the 1/3 side. Well, what do you know about 2/3 and 1/3? I know that 2/3 is twice as big as 1/3. So if I multiply this by 2, I will have the 2/3 measurement. Okay? And then the next question was, what's CK? Well, we did 12 times 2 to figure out 24, and then all you got to do is 24 plus 12 to get the 36. That's the full length of the median. The next one says EU, and so I did 21 times 2/3, and that's 14. So let's look at the picture. So EM was 21, the whole length of the median, and EU is the 2/3 part of it. So yeah, it makes sense to just do 21 times 2/3, and that's 14, right? So that would make UM the 1/3 part, and so 1/3 of 21 is 7. So whenever we see UM, we're going to put a 7 there. And that's exactly what example 4 says. MU is the same thing as UM, isn't it? So now I'm just going to get to JU. I did 9 divided by 2 and I wrote 4.5. So why did I do that? Well, UD is 9 and that's the 2/3 part. How do I know it's the 2/3 part? Because it's coming from the vertice or the corner of point D. So if this is 2/3, then this is 1/3. I know 1/3 is half of 2/3. I know kids are not a fan of fractions, but think about it. 1 is half of 2, right? They have the same denominator. If you have 1/3 plus 1/3, you have 2/3. Okay? So just cut this in half, in other words, because this is a 2/3 segment. This is the 1/3 segment. I'm not going to multiply it by 1/3. That's probably the most common mistake kids are going to make. But if this is 2/3 and this is 1/3, that means this is half of this. Okay? The only time you use 2/3 and 1/3 is if you know the whole thing. If you know what DJ is, then I would take DJ and multiply it by 1/3 to figure out UJ. Or I would take DJ and multiply it by 2/3 to figure out what UD is. Okay? But I'm not going to multiply 2/3 or 1/3 by anything on the inside if I'm given one of the inside things. So the inside parts, what you know is that this side is going to be twice as long as this side because it's coming from the vertices. So cut this in half, cut the 9 in half to figure out what JU is. 9 divided by 2 is 4.5. So JU or UJ is 4.5. The last thing to go over is how did I get JD of 13.5? Well, I added 9 plus 4.5. I added together the 2/3 part and the 1/3 part. 9 plus 4.5 is 13.5. So you should be able to go backwards. Remember, the whole segment is 13.5. If you do 13.5 times 1/3 or divided by 3, you would get 4.5 right here. If you did 13.5 times 2/3, you would get 9. Okay? So you should be able to go backwards in that sense. Just remember to never take these inside measurements and multiply it by 2/3 or 1/3. Alright? You're either going to cut those in half or times them by 2 based on what part you are given. This was the 1/3 part, so I would times it by 2 to get this 2/3 part. Okay? I know it sounds confusing, but I feel like, to me it makes sense, so I hope I'm explaining it in a way that makes sense to you. Okay, so this section was called medians and altitudes, right? So the next thing to talk about is the altitude of a triangle. So the definition is an altitude of a triangle is a segment from a vertex to the line containing the opposite side and perpendicular to the line containing that side. An altitude can be on the interior, exterior, or on the side of a triangle. So the main thing to take away is that it's a straight line going up and down, so that's why it's perpendicular, making a right angle. So they didn't draw it, but if it's the side of a triangle, that's a right triangle. So BD would be an altitude because it's going to make a right angle, or it's perpendicular to side AD. So it's going to make that right angle at angle D here. So that's what it looks like if it's on the side of a triangle. And then the textbook drew these images here. So if it's on the inside of a triangle, it'll be on the inside of an acute triangle. Alright, I don't think that's a major detail or anything, but this is an acute triangle, and an obtuse triangle will have an altitude have to be drawn on the outside of it. okay? So in this example here, I'm going to identify the altitudes of triangle ABC. And so it's kind of easy because they're already labeled with the right angles. But yeah, basically you're just looking for the line or lines that make right angles. So that would mean AF is an altitude, BG is an altitude, and CD is an altitude. And that's pretty much it. So earlier when we talked about the medians of a triangle, they all met at the centroid. The altitudes of a triangle can all meet at something called the orthocenter. So it's very similar. You got to pay attention to the details here. Similar to the median problem, the median example with the centroid, these lines are coming from the vertices, but you'll notice that it's not making congruent segments, so it's not intersecting at the midpoint of these side lengths, and it's also making right angles. You'll notice that the centroid ones were not making right angles when it intersected with the median. So in this unlabeled image, we're going to identify all the lines that are perpendicular to one another if point U is the orthocenter of triangle ABC. So if point U is the orthocenter, then that means line AS is going to be an altitude, and so that means it's going to be perpendicular to BC. And so CR would be an altitude, and that would be perpendicular to side AB. And then BK would be an altitude, and that would be perpendicular to side AC. And that's pretty much all I'm doing in this example here. But if you want, I wrote it down right there, and you can pause and write it down on your notes as well. The last part of these notes is basically just kind of like a little chart that I saw in the textbook, so I took a screen grab of it. It basically summarizes the definitions from the past two sections because they are pretty similar and they're very easy to get confused. But the circumcenter is formed by the perpendicular bisectors, the point of concurrency of the perpendicular bisectors. The incenter is formed by the point of concurrency of angle bisectors. The centroid is formed by the point of concurrency of medians, and the orthocenter is formed by the point of concurrency from the altitudes of a triangle. And then there's a drawing of each of these and then a listed special property. So feel free to refer to this as much as you need when working through problems that deal with these four types of points of concurrency. But that's going to draw these notes to a close, so thank you for watching. Hope you learned something, and goodbye.